Good morning, AFDA students. In this video, I'm going to explain the steps for completing your Project 3. In my sample project, I had a theory that a student's SOL score was related to the grade that they were earning in a class. And so that was the title of mine. For yours, you might decide to survey people the same as I did and see if one number depends on the other. Or you might find a data set online where something has been changing over time. And if you need help figuring out how to do your data set, please talk to your teacher. So in my survey, I asked students what was their Algebra 1 grade and what was their Algebra 1 SOL. And I recorded those on the table here. If you do a survey, you can do the same. Or if you find a data set online, your X column might be the year, or it might be a month or something like that, and then the Y would be the thing that changed over time. You need to get a graph, and sometimes we've had some strategies for copying our tables into the graph. They don't copy directly into Desmos, but we had a method where we copied them into a Google Sheet and then into Desmos. But if you end up typing it in, I'm going to help you fix so that you can see your points. So I took my table and I typed it into Desmos. And here's my table. When you type it into Desmos, you're going to have to hit the plus and choose table and then type it all in. But here's my table, and I don't see any of my points, and that's because the numbers that I see are from -10 to 10, from -6 to 6, and I can't see any of these numbers. A lot of people will try to zoom out, and you can eventually see the points by zooming out, but the problem is they don't always look exactly how you want them to. See, the points are all right here. There's all of this blank space all over the place. So instead of zooming out, I'm going to recommend that you change your axes with the graph settings, which is this tool right here. So looking at my x-axis, I seem to have numbers that are between 46 and 97. So for my x-axis, I could choose to start around 40, like right below 46, and I could go up to 100. But I kind of want to see my y-intercept, so I'm going to actually choose to start at 0. And then for my y-axis, these numbers are all in the hundreds. It looks like my lowest one is 374. So I'm going to try going from 350 to 600 and see how that looks. All right, I feel like I need to go a bit lower, so I'll just try 100 to 600. Okay, and that looks decent. Let me take a look at it. Yeah, I think that looks decent. Okay, and then after that, you might want to put labels on it. So going back to graph settings, next to the x-axis, I can put algebra grade. And then next to the y-axis, I can put SOL score. Okay, and then those labels end up right there on my axes. You can actually do this with a text box if you prefer, but they are here now, so I don't have to do that. And then just when we're doing you can take your picture from this, but when we are doing our regression, you could add your line before you take the picture if you want. So I'll go over here to the plus, f of x expression, and the regression in Desmos is y1, and you just hit the regular one, and it will go down like that. The tilde is right below the escape, but I have to hold down the shift, and then I can get the tilde. mx1 plus b. All right, so that is my line of best fit, and I'm going to come back for that M and B value, but for now I'm going to get the picture. So to get the picture, I need to go over here to Share Graph, Export, and if you want to, you can change your line thickness, that's up to you. Download, and then over here I need to open it. And on the top right, there are 3 dots, and you're going to click that, and then you can choose to copy it. And then you're going to paste that into your project. So going back to my sample now, here is where I put my graph. And looking at my graph, I'm talking about the practical domain and practical range. Remember, domain is X values and range is Y values. So I need to think back to what actually makes sense in my situation. Since my X values are Algebra 1 grades can be between 0 and 100. So that's how I have 0, 100. This is interval notation, and it means all of the numbers between 0 and 100 are possibilities. For the SOL score, I thought maybe it would be 0 to 600 because you could get an SOL score from between 0 and 600. But then I looked at my graph and I kind of adjusted that a little bit. So looking at my graph, my y-intercept over here is 154.8. And that means that if I actually scroll back a little bit, these values would be negative for grade, which you can't have. So that tells me right here, that is my starting amount. That's the lowest my SOL score could be. So I used that number instead of 0 in my sample right here. So SOL scores could be between 154.8 and 600. Here's where you write the equation. Remember that the equation of a line is y equals mx plus b. Instead of the m, I put 4.05. I got that number in Desmos when I did my regression. Down here, I got m equals 4.05. I also got b equals 154.8, and I put that here. After you write the equation, you want to explain what the m and the b are. So you can start by saying m is the slope, but then your situation should be different from mine. My slope is the change in SOL score divided by the change in grade. So it's always going to be the change in the y divided by the change in the x. If you forget what your y and your x are, go back to your table. This is your y, and this is your x. And then I explained that a little bit further. So since this is my y, this is how much the SOL score is changing. So when my Algebra 1 grade goes up 1 point, my SOL score goes up 4.05 points. B is the y-intercept, and the y-intercept is the SOL score right here, and at that point your algebra grade is 0. So it is your SOL score when your algebra grade is 0. All right, in the making predictions, you are going to be doing 2 different things. So the first row is completely separate from the second row. It says come up with a value for the independent variable, and that's the x. So I said, I wonder what my SOL score would be if my grade was 100. So going back to my table, my x is the Algebra 1 grade, so I chose a grade of 100. You can choose any value you want for your x that's not in your table. Then I took that 100 and I put it in my equation for the x. So what you can do is come back and copy this equation, paste it here, but then change your x value to the number that you chose. Then you're going to do the math, multiply and add, and you're going to get the number here. So my SOL score would be about 560, I rounded that, if my Algebra 1 grade was 100. So that's all done. Then you start over and you come up with a number for the dependent variable, which is the y. So if you forget what your y is, go back to your table, and that is the SOL score. So I came up with an SOL score of 400, and I wanted to know what the Algebra 1 grade would be if your SOL score is 400. You get to pick whatever number you want for your y. So I put the 400 into my equation for the y. Remember, it's this same equation, so I copy this one, paste it here, and then change the y to 400. And to solve this, I subtracted the 154.83 on both sides, and I divided by the 4.05, and I got that it was a grade of 60.54. That would give me an SOL score of 400. Okay, in the analysis, you are going to answer the questions in your own words. So you may read over mine, but please don't use my same wording. So the first one is, what kind of data fits a linear model? So remember, this is a linear model. So you're just trying to describe what kind of points would fit a linear model, because you know if the points, for example, were all over the place, then that would not be described by a line. Is linear regression the best model for representing this data? So if your points seem to line up, then you can say yes. If your points make another shape, like a U shape, or if they go all up and down, then you can say no and describe why. Is your slope positive or negative? So that's just going to be depending on your line. Look at your line. And your correlation should match your slope. So positive slope is positive correlation, negative slope is negative correlation. Based on the correlation of your scatter plot, what does this mean about your data? So for mine, because it's increasing, as my Algebra 1 grade increases, my SOL score increases. If yours is decreasing, it would be different. And what does the y-intercept mean for your data? That's actually it's really a little bit repetitive, because that question is also answered right here. So you can use the same sentence that you have here. All right, and here is when you're just going to put all your thoughts together to conclude this. So the equation y equals 4.05x plus 154.83 can be used to predict the SOL score y based on the Algebra 1 grade x. So for everybody, it can be used to predict whatever you have in y based on whatever you have in x. For mine, I said the points are not very close to the line, so I think the prediction might not be accurate. For yours, you can tell me whether the points are close to the line and whether you think the prediction is accurate. If your Algebra 1 grade is 0, your SOL score is about 155. That is the same information that came from the y-intercept. And then your SOL score increases by 4.05 points every time your grade increases by 1 point. That is the same information as the slope. All right, and then once you've written your conclusion, you can turn that in.